Thank you for joining in. I can see many known names and existing customers, colleagues, and a lot of you all. You made sure you attend this workshop with us, and I'm really grateful that you made it. We'll make sure we give you maximum value out of this. Thank you for joining in. So today we're going to talk about from weeks to minutes, the future of fixture design and manufacturing. And my name is Swapnil Sansari. I'm CEO and founder of Divide by Zero Technologies in India. And today I have privilege to introduce you to a company called Trinkle. Trinkle is Berlin-based company, and they have worked very closely initially in their initial days with Audi Sports for their R8, e-tron, and GT models. And they had issues with fixture designs, and close to 200 fixtures were initially designed with Trinkle's solution, proven, tested, and that's how Trinkle started and Fixture Mate was born. And today they are serving the world with automation and fixture designing, and and with their intelligence there. I have Kaushik Sriram from Trinkle, who's their application engineer. Hi, Kaushik. So I'll just start and initiate this, the workshop. So today, again, we'll be talking about why Fixture Mate and why we are doing this, and how this is very important in terms of changing the process or understanding what's new, and in terms of what is the solution that we have to this. And towards the end, we can definitely get next steps, how we can get started. Our team can share a link. So in between, I think many of you have joined, and I know it's very important time that you're spending with us here. So we'll be sharing a link. If you need, and if you find any application suitable, and if you want to quickly leave the meeting, you can connect on that link and set a meeting with us in any next week or any days that are suitable slots. So you can book calendar. My team will share that. So before I start, we did initial survey with around 1,500 manufacturers in different domains, especially manufacturing. And in terms of fixturing and the delays and the pressure that they have. And I think most of you are from, will be surprised, but 30% of manufacturing delays happen because fixtures arrive late. And the information was very, very interesting. This is India data again. And the trouble here is most of the component that are designed are in 3D. Then goes the 2D designing with tolerances, and once they get the tolerances, the fixture designing process starts. After that, there are initial trials, there are changes. Because fixtures are made using traditional methods, again, a lot of back and forth on the tooling, and actual initial trial, manufacturing trial, is delayed by at least 30% on an average, is what number we're getting, and it's a big number. And we are here to solve this problem and look at the solutions. We tried this back in 2019 as Divide by Zero initially. And let me just walk you through what happened then and what we are offering now. So this is an assembly line video that I'm showing you where 3D printed fixtures were deployed. So these were again hybrid fixtures, and this was when we started working on these fixtures in 2019. Again with Tokayoki and a lot of complex, engineering and components that you can see. And there were at least 1,200 fixtures that we delivered with designing, 3D printing, and processes. Process time was again here, it was still large. Traditional used to take 45 days, but this still took 15 plus 2. I mean, 3D printing was possible. but design time and reiteration and again going back and forth on that took a lot of time. That did not work out majorly because the design process was time consuming. We were dependent on the experts who could design fixtures, understanding tolerances, going back and forth on trials and then coming back. Again, a lot of revisions here, and that added to delays. With 3D printing and the process and the materials available at that point of time, the fixture strength was not that great, and again accuracy and tolerance issues were there, and the process was not optimized, resulting we could not bring this solution to many of the customers that we were trying to and intended to. However, there were two major challenges. One is design, which is about the complexity, expertise gap, and iteration delays. And second was development challenge, again, in terms of manufacturing these fixtures. So when we talk about the first challenge, we are going to address two challenges here in today's workshop, is where I introduce you to Trinkle and Fixture Mate. So Kaushik will take over and explain you about Fixture Mate and how it works and how we are solving this. Over to you, Kaushik.
Thank you so much, Swapnil. I hope I'm audible right now.
Yes.
Perfect. So let me share my screen. Yeah. Thank you so much and greetings from my side. I'm Kaushik. I'm an application engineer with Trinkle. Swapnil has gave us a good introduction and set the stage on the problems that you usually have during manufacturing. So let me take it from there and try to explain how FixtureMate and the products from Trinkle can actually solve your issues. So Uh, gone are those days where the fixture manufacturing is just related to machining or any other traditional manufacturing, right? Because of the advancements in additive manufacturing technology, we can now print design fixtures and even make fixtures at a lower cost, much more reliable and with faster lead times. So this for a company is really attractive, and they are trying to switch to 3D printed jigs and fixtures right now. And close to 58% companies are looking forward to switch to 3D printed jigs and fixtures as well. So when we say that there are 3D printed jigs and fixtures, so what are we talking about? So what are the possible things that you can make with it? So I've just given you some of the list, as you can see on my screen. So we'll start with the assembly fixture. You can think of this scenario, right? When you have a workpiece with you which needs to be assembled, but the problem is it is not going to stay stable in a particular orientation that you need. So what do? So you can easily use 3D printing to make it in a quick way, fix it at a particular orientation, and then do other manufacturing processes like helicoil insertion, or you can do assembly operations, fastening certain parts on top of it. All those can be done when we talk about assembly fixtures. The next category is CT scanning fixtures, where it is even more interesting, where the part and the actual piece which is holding the part, the fixture should be of different material so that the seating scanning procedure works really well. So that there should be a difference in densities as well. So additive manufacturing would be a great fit for this. And next is bonding and welding fixtures. And this is a big umbrella term, right? So we are not reducing ourselves just to arc welding or TIG welding. It is a big term. It can be bonding in terms of adhesives, or it could be even laser welding as well. So it is a complete scenario list that we are talking about here. When you have different pipes of different bends, you need to hold them at a particular orientation, stable enough till you finish your operation. So 3D printing is a best way to do it. You can make optimized support structures to do it as shown in the image that we are seeing here, right? So next is the inspection fixtures. Let's say you have a part that you need to do quick check on it, whether it is actually good or not. So we can design go, no-go gauges in a faster way with that. You can optimize your entire inspection process with it. What you have to do is just try to insert it and take it out and then have an understanding whether the part that you are actually trying to inspect is qualified or not. That is possible as well. Next is carrier tray. So you assume that you have a big factory and you need to move your parts from one place to another. You cannot just dump all those parts in a single box and then move it, because it will lead to scratch. And once the part is scratched, then it is a big headache to rework on them. It all involves cost. So the case that I'm showing here is a classic example where a 3D printed structure, with because the 3D printing material has different hardness level, so it won't naturally scratch your parts. It can be held securely in a carrier tray or a carrier tray like shown here, and you can move it in terms of logistics easily from one place to other. So that is also possible. And last, we are talking about CMM fixtures. So for CMM fixtures, you need to hold the part with minimum contact, but it should also be stable enough so that the tactile measurements does not move the part, right? So 3D printing is a good scenario for this as well. So all these scenarios can be thought, and FixtureMate provides solution to every single category of this. But as I said before, this is not the complete list. This is some of the list that I am showing here for at the moment, just to give you an idea of what we can do with 3D printed fixtures. There are a lot more applications like laser marking, laser engraving as well, which would be an interesting use case to some of you. So just to wrap it up, we have clearly seen that the 3D printing is attractive to your company. We have clearly seen that there is a possibility of creating multiple fixtures and stuff. There is still a puzzle piece that is missing, which is the design time. So who takes care of all these designs for you? Challenges when it comes to designing jigs and fixtures, right? So let's say you have a sudden requirement of 100 plus fixtures in your factory. So who will design it? So either it has to be a CAD engineer or a mechanical engineer. He has to devote his time to design it, but he has to be distracted from his normal day-to-day activities or high priority tasks. So this would actually delay your entire workflow. That is a big challenge, or a big bottleneck that would happen in your company. Then the second thing is the cost to design a fixture is not easily estimatable, right? Because there are a lot of factors involved: the size, shape, complexity of what fixture you are trying to use, that determines the cost. And there is also a hidden cost which is going on here. Let's say the requirement from a shop floor has to be translated into the designer's table, right? So they are sitting at different places in the company. So one has to do multiple communicate. One has to go through multiple communication chain or administrative chains in order to make it happen. So all those things will be adding cost to you without even knowing or understanding in the background. And next is the setup cost. So what do I mean by setup cost is um, we would be requiring a decent laptop or a decent PC in order to run all these CAD softwares for all the doing, right? So this is also a cost to the company at the end. So because of all the previous reasons that we have just discussed right now, so the cost of the just the design cost of the fixture can take up to 30 to 90% of your total fixture cost. So this is not so good, right? So we have a great potential from technologies like divide by zero, which can accelerate your 3D printing manufacturing process, but the bottleneck is still lying in the design. So that is where FictionMate comes in, and we try to solve your problem. So FictionMate is nothing but an intuitive cloud-based software. So it can allow anyone on your organization to design fixtures in minutes, not hours, just minutes. So how do we do it? When I say intuitive, what do I mean by that is whenever a certain operation is involved in the fixture generation, like let's say cavity making or a subtraction feature, that is a repetitive task. So what FixtureMate does is it identifies all the repetitive tasks and it switches them into an algorithm-based approach. And at the end of the day, for the user, it is just simple clicks and few interactions that they need to do. So whatever is the complex steps that is happening in the traditional CAD software, we are taking it, try to put it behind the algorithm, and we are enabling a simple interface to the user so that they can do it without any issues and in a faster way. So because of this design automation that we are talking about, we are almost reducing 80% of the tedious manual repetitive work. So when you remove all the manual and tedious work, so what you left with is an easy, intuitive interface that anyone in your organization can do right now. It is not just limited to the CAD experts for designing the picture. So because of this, you can speed up your production timelines and reduce the overall cost. And since it is a cloud-based software, you don't need to invest a lot on buying a good quality or a decent quality laptop. You just need a good internet to access it anywhere from the world. So this is just a summary of what FixtureMate does and solves for you. So since all the repetitive task is taken care by the algorithm, there is no manual error involved, right? So when you try to repeat a task again and again, there is a chance of human error that might happen somewhere during the design phase. But when it is behind an algorithm, which is very strong and it does it for you, it will always try to get designs right the first time. And you can always do easy modifications on the go. It is not referenced or it won't hurt you in any way because I have little bit of experience with some of the CAD softwares and all the features that you do might be interlinked with each other. So if you change a feature or delete a feature, then it might also lead to other features getting affected, right? So that makes editing a little bit heavy task for you, but FixtureMate can do it easily. And overall, we eliminate the design bottleneck by bringing the fixture time from hours to minutes. So we will actually see everything in live so that we can understand how and what FixtureMate can do, right? So let me try to switch to the live demo right now. Let me double check whether my screen is visible. Yeah,
Yes.
okay, perfect. So before we start, I would like to just give you a brief overview of FixtureMate software, right? So this is the interface that you are currently seeing it. I hope you can see my mouse pointer as well. So all the important icons that you need for designing the fixture is kept on the leftmost pane, and it is arranged in certain way that it is we have to go from the top and the user can work their way around till the last point. So it is all arranged in a nice fashion. And we also have couple of view controls, which is like what it says it does. So we have different views to uh, quickly manipulate it. We also have a view cube in with which we can quickly set the relevant views as well. So this is the basic overview, right? So the first step is in the fixture generation process is importing a workpiece. Let me go ahead and try to import a workpiece. So let's see, I have imported one part. Let me try to import another part on top of it. As you can see that these two parts are assembled together. So this can happen if the user properly exports their STL files with with the correct coordinate system. Then when it is inside the fixture mate, it can be assembled in a nice way. It will get assembled in a nice way. So this is there. Just give me a moment because my screen is hiding a bit. Let me resize it. Yeah, this works. So Yeah. So we can, once if it is exported properly with proper coordinate system, it will get the way you want inside the software. And we have two markers that we are seeing here with which we can easily, with one click, we can see the axis, gizmo axis, with which we can move the part to whatever orientation, whatever position that we need. If we click it twice, we can get the rotational gizmos with which we can easily rotate. You can see the degree uh, popped up as well. So you can rotate it to a desired location, or you can just reset back how it is initially imported, right? So this is an example. And you can always try to link both work pieces so that it all moves together. So I have enabled the linking operation. So what it does is if we try to move an object, both objects move together. So that is there. So this is the quick way of moving apart, but we can always do precise movements with the left pane. So I can type in XY coordinate values here, let's say like this, and I can try to orient the path the way I need. So once this is done, let me try. I mean, we are trying to make a laser marking fixture, and the user has a requirement to make lasers on the topmost portion. So which means it should be pointed up. So we can do it in two ways. One, we can directly type in the values that we need, or the neat way that I would like to show here is you can click on a part and there is a feature called align to XY plane, and you can type in a value. So what it does is whatever point you pick, that point will be will face the plane at a distance that you have specified before. So uh, we have set a distance of 50 mm. So the bottommost point that we have picked right now is at a distance of 50 mm from the plane, like what is shown. So this is there. Let me also try to rotate it 90 degrees so that it is horizontal and it is looking a little bit nice. So the first step is to import part, orient it in a desired way. So once you've done that, you have the next option in our list is selecting a base plate. So FixtureMate offers 3D printed as well as standard component base plates. So when I say 3D printed base plate, as the name suggests, both the base plate and the support is exported as a single STL file. You can put it in your printer and directly print it. But if it is a standard component, there will be plates like this, and you have to design separate supports and then mount it separately. We will see that in detail, but for the sake of a demo, let me try to go ahead with rectangular base plate. So I have chosen rectangular base plate. You can type in the values that you need, or you can type in fit size. So what it does is, let me switch to the top view. So what it does is it takes the extremities or the bounding region of the workpiece or whatever it is inside, and it will try to offset it by the value that you have specified here. So if I type in 20, it will get offsetted that way. There is also an option to enable mounting point in a quicker way so that you can do it, you can change the diameter, you can change the XY offset here as well. So once this is done, the next step is to create supports to actually hold this workpiece. So FixtureMate offers a lot of nesting options or support structures, right from custom shape, conical shape, cylindrical, and rectangular. But for the sake of demo, let me just take a rectangular part. And as you can see, once I click it, I have an option to freely move and set the dimensions that I need. So I can click it up here. You can move the supports in a faster way by holding the center. You can rotate it to the value as shown here. You can click on any points and then move it to the way you need. If you need precise adjustments, you can always do it here. Let's say I want to 60, I want to place it at center. I want no rotation on my supports. You can do it with the left pane as well. But the right is for fast, uh, fast modifications. So I have done that. So let me go ahead and do a second base plate as well. So I have used a keyboard shortcut of space. So it tries to repeat whatever the last action that I did with the fixture mate. So the last action that I did is creating a support. So that is being generated right now. So once you are happy with the size of your support structure, the next step is to determine how long your support structure need to be, right? So there are three ways to do it. One, you can just directly drag it and then do it. Or the other way is just typing the values here. And the really nice way that I would like to demonstrate here is you can right click on a support and click set height. So what it does is basically it allows you to pick a point anywhere on the workpiece. Let's say I'm picking a point here. Did you notice what happened? It just extends the support to the point that is actually being picked. So that is there. Similarly, let me try to pick some different height like this. So yeah, you can see that the support is picked. So once this is done, the next step in our process is the subtraction. Let's try to subtract it. It is in a single click. You can see that the feature is getting subtracted. Uh, did you notice something here? It is uh, not a simple a minus b subtraction or a Boolean subtraction. It is a projected subtraction so that you don't see the undercut or a piece which is preventing the workpiece to be lifted up. So that is done automatically for you. So it can always ensure that you can take the workpiece from the Z direction. You can take it like this and then put it back. So the software will ensure that the cavity that is generating is taking care of that. But what I would recommend you is to change this offset. This is a global offset, which depends on the tolerance of your actual workpiece and the material that you are trying to print, because it can shrink and it can make it harder to fit in, or it can make it looser to fit in. So this is the parameter that you can change to make it more fittable, let's say. So I have given an offset of 0.2. Let's say if I give 0.5, you can see that it is globally extending. So the software will also give you frequent reminders to save your session, because since it is a cloud-based software and we don't store any data, so it is the user has to ensure that they save their session files at regular intervals so that they don't get it lost. So yeah, we have increased the offset as well. So this is done. And the next step is adding clamps. Clamp is not required for laser marking use case, in my opinion, but for the sake of explanation, let me try to enable it. So we have different clamps, right? We have good selection of standard clamps that is already available. Let me go ahead and pick maybe this. So I can pick it and then click on a point, and then the clamp will be positioned in a faster way. Uh, the support structure for the clamp is also auto-generated, and the screw holes, the thickness are all automatically taken care for you. So if you want to do some changes to the clamp, let's say you want to move this to a different location, you can click on the marker and then move it to a different location, and the software will take care that it positioned properly in terms of height and orientation, right? So you can also have the option to change the direction or the rotation of the clamp. Let's say like this. to the position that you need. That is also possible with FixtureMate. So once we have imported the part, oriented it, created an cavity structure for it, hold down for we held down using a clamp. So once this is done, we can go ahead and try to add text labels to our fixture. So we have an height or depth parameter. So if we give negative value, it is an engraved text, but if we give a positive value, it is a projected text. So that is the explanation here. So let me go ahead and type in the text that I need. I am typing FixtureMate, and let me try to pick any 2 points, and let's see what happens. So whatever the text that we are trying to enter, right, it will always lie within this 2 points, and you also get a prompt of what is the text height there, so that you can ensure whether the text is visible enough or not. And then you can uh, type in, you can update it easily like this. And it will always ensure that the text lies between those 2 points. It will adjust the height accordingly based on that. And you can place the text anywhere, right? On the curved surfaces, anywhere on the 3D printed geometry, you can place it. So the next option is adding holes and cutouts. So these are the standard hole option that one might usually often use. So we have these options as well. Let me go ahead and try to do a counter bore. You can type in all the values that you need, give set position, and you can click anywhere on the 3D printed surface, and it will uh, enable the counter bore for you in that region. You can also try to make it a through hole so that you basically see it from the other side as well. You can quickly, you know, drag it to a different plane. It will automatically be referenced to the bottom plane as well, like what we are seeing here. So it is completely flexible to do it. So there is also cutout options available. Cutout, you can think about something like if you want to have some wires on your 3D printed surface, or if you want to remove certain features from the fixtures, you can do that using the cutout option. So I'm just enabling the through cut here just to show you how it is coming. You can see that the cutout is also there. We also have pattern option for cutout. If you want to pattern it, linear pattern is supported. You can do that. And there is also other set of cutouts available such as sphere and cylinder. So that is there as well. Probably one more nice feature that we can see is we can set the cutout on surface. Similar to what we have seen for set height, right? There is also an option to set cut to surface as well. You can click on a surface, and this box cutout would be extended till the point that we picked on the workpiece. So that is also possible. So let me go ahead and yeah, I mean, let's leave it like that. Probably we'll delete this one because it might not be needed. So yeah, this is done. Let me go ahead and try to create then show you the next feature, which is called the follow feature. So this is an optimization feature, right? So what it does is instead of having like a thick solid structure on all together, you can create hexagonal structures like this. So you can adjust the cell size, inner wall thickness, outer wall thickness for the hexagon, and you can basically create a hollow mass optimized structure as well. But this is not recommended for 3D printing, but please consider your 3D printing technologies before using it. But this is mostly targeted to SLA and SLS options, if I'm not wrong. So once this is all done, let me go ahead and try to, the last step is just to download and see the picture. You can type in any name. So let me just type demo2 and download the picture here. The hexagon is an heavy operation, so it might take some time to generate the STL. Let's wait for some time. Okay, so this is done. Let me go ahead and save it. So you can see that the fixture that we have generated has been exported as an STL, which you can send it to the 3D printer for directly manufacturing it. So I hope you got a good feel of how quick it is to design a fixture like this, right? Um, Let me try one more thing. Let me go ahead and switch off the hexagon. I'll try to give you a scenario when in which you have made a 3D printed fixture, base plate fixture like this, and you have a need to switch to a different standard component, let's say. So how will the workflow look for you? So you already have a session like this. So what can we do? We can go ahead and directly override the base plate to the perforated panel. You can type in the dimensions you need as per your data sheet of your perforated board. You can type in mounting holes. We also support circular base plates as well, but for this demo, I'll just leave it at rectangular, and then we'll wait for some time. And the base plate is automatically updated in a quick fashion. So I think you can get a sense of how easy it is to change mounting, right? Let me go ahead and do something here because this is not mounted. Let me go ahead and try to do a different operation. So it is giving me a warning saying that I have two rectangular supports and a clamp, which is not mounted to the base plate. So the software can give you a warning of that you have actually missed it. So you can go ahead and either click on the spanner icon here, which will directly prompt you to the mounting interface. So you can directly click on the points that you need to generate the mountings, and you can click finish, and you can see that the mounting points are automatically generated for you. Similarly, we can do mounting for other aspects as well. Like this, I'm just picking a random location, right? But yeah, you can, I think you would be much more experienced in picking up the right location, but I'm just, for the sake of explanation, I'm just picking up some uh, random locations. So yeah, this is done. And once this is done, you can still export it as an STL. But now, instead of two STLs, I mean, instead of one STL, we should get three STLs because it is a three individual files that we are talking about. Let me go ahead and keep it as demo3, save it. Demo3, it is here. Let me try to extract it. Demo3. Yeah, so we have three options, right? So one, try to open with 3D viewer. You can see the part that we have just designed with the fixture is also there. Similarly, the other two options as well. So, so yeah, this is the basic overview of Fixture Mate. So I'll just, I hope I have given you an overview of how easy the software is. There is also pattern operations available on the workpiece itself, so that is also supported. But I think this would have given you an overview of what the software can do. So let me jump back to the presentation and continue from there. So in summary, we have seen till now what are the what are the challenges with the traditional manufacturing and why 3D printing is attractive to the customer. And then we have talked about how FixtureMate can solve your design problems. We have seen a live demo. And now let's try to set realistic expectations for FixtureMate, right? So what is possible and what is not possible when you think about FixtureMate? Because FixtureMate is not like the traditional CAD software, it is a design automation software. So you'll try to understand what is possible here. So single removal direction fixtures is possible, meaning the fixtures can only be put in and put out from the Z direction. Other directions are not supported at the moment. And when we talk about the file size and file formats, the total files should be lesser than 100 MB per session of a fixture. So what do I mean by that is, let's say you upload 10 different files into the fixture mate for a fixture generation. The sum of all the files should be lesser than 100 MB. This limitation is because it is a cloud software, so everything is handled in the server. So this is a good limit that we are setting ourselves so that you have the best performance at your end. And in terms of file formats, we support STL, STEP, and .3mf. Uh, FixtureMate works in STL format, so even if we try to import STEP file, it gets automatically converted into an STL file inside. There are a lot of optimization options also available, which tries to downsample your file into a good level before using it inside. But we would always recommend you to export STL with a good decent quality, not with too much resolution, but with an optimum resolution so that you have better experience with FixtureMate. So I've talked about it. Let's see what the users think about FixtureMate, right? So uh, we have Audi Sport. I think Audi Sport is very well known to everyone who are here. So there was a factory in Germany who had a requirement for designing around 200 fixtures for their Audi e-tron and other cars that they are trying to do there. So they have faced with a bigger challenge, right? They had a sudden volatile requirement of 200 fixtures, and then the designers were already occupied with existing projects, so they were trying to find what would be the best solution for them. So with FixtureMate, what they have did is they have reduced the fixture design cost by 80%. So they have brought down, which would they have estimated it to be 6 weeks, but with FixtureMate they have designed 200 fixtures within 48 hours. So the average design time that they have reported per fixture is 15 minutes. So you can also see the 3D printed fixture that they have used in the slide here. So mostly the users were trainees, process and production engineers. So they don't want to uh, tax their existing CAD engineers. So the other engineers stepped up and it was so easy to use. So they have used it and they have even optimized it and they have done it at a very fast level. Same story, but with a different reputed customer as well. This is Eric's. So they are also into additive manufacturing, and they also reported a design time of average design time of 15 minutes, and they estimated that they have saved around 100K euros in terms of adopting FixtureMate and adopting 3D printing technology. So next and final use case is Deutsche Bahn. Deutsche Bahn is a leading rail management system from Germany. So they do it, and they mainly used it for maintenance fixtures as well as logistic trays and fixtures. So they have reported an average time of 25 minutes. So these are some of the work pieces and the use cases that they have that they are using it in their company. So in summary, with FixtureMate, there is a clear design time reduction of 92% as reported by Audi. And since it is actually easy to use, the onboarding time that you require in order to learn this software is very less. You can do it in around 1 hour and then directly jump into the design process right away. So that is also a good point. And Erics has reported a return of investment of 6 times. So this is also something to be noticed. And yeah, I hope to see your company's success story with FixtureMate and Divide by Zero in our portfolio as well. And thank you so much for listening to my slides patiently. Now I'll hand it over back to Swapnil to take it over from here. Thank you so much.
Thank you, Kaushik, for joining us here from Germany. And I'll just share my screen. I hope it's visible. Yep. So, we are very proud to be associated with Trenkle for supporting in applications and deployment of Fixture Made in India. Um, we did work and developed a lot of solutions. We had a theory in Divide by Zero, or you say it was a transformative kind of uh, philosophy that we wanted to move from something we called as cherry to cake, for from prototyping to manufacturing. And I think with Fixture Made, we always had this vision, and I think this is going to be accelerated. So in that journey, coming to the second solution of how you can deploy this. So FixtureMate is not limited to 3D printing, but you can also export these fixtures and use it on CNC platforms, use it with your standard aluminum base plates, and so on and so forth. But 3D printing is one of the options. Yes, we have a lot of questions here. Thank you, everyone. Please park your questions in Q&A, and we will take that in the end. Also, in the meanwhile, if you have to leave, or if you want to set up a meeting, I've shared the link in chat. You can block your time there, and we will get back to you, and we can sit with you one-on-one for your application. And I'll just move ahead. So recently we have developed and deployed one of the fastest 3D printers that we have ever seen and built. So with that machine and FixtureMate, we were able to achieve something which was not possible earlier. Let me share the video with you. So Quantum Pro 500 is one of the large format 3D printers that is specially developed for fixturing applications, where this machine can print composite materials like nylon carbon fiber, nylon glass fill materials, ABS carbon fiber glass fill, PETG carbon fiber. And we are testing more than 30 different materials right now, including polypropylene, including polycarbonate, glass fill and carbon fiber materials, and also ensuring these materials are available in extremely affordable cost. This machine can do at peak around 550 grams per hour kind of deposition rate, which is really high when it comes to high-speed 3D printing. Again, this 3D printing option is something which is possible, but FixtureMate can also work with your CNC workflows. So Quantum Pro and FixtureMate, you don't need CAD CAM and any expertise. You don't need extra software. You can have a standard normal computer which can work through web, and on cloud you can design and develop and deploy these fixtures. Uh, Again, if it's cloud based, you can communicate with different team members across the globe. Beyond this, if if it is required, there can be additional processes. There can be ways where you can add offsets to the final design files. You can change it. You can use hybrid workflows like 3D printing and CNC machining to achieve better accuracies, and that is completely possible. But we cannot cover everything and every type of fixture in here in this workshop right now. I'm really grateful, Kaushik, given his time, and he's walked us through the workflow. However, if you want, we can definitely get in touch, and I've shared the link. I think my team can share the link again now with you. So if it's about bonding, welding fixtures, again, laser welding, laser marking, it's possible. CMM inspection, go no-go gauges, assembly fixtures, Again, various type of fixtures, yes, possible, and with different types of standard grid plates, and CMM inspection plates, a lot of possibilities. Uh, One question we often get is that what would be the timeline or what would be the strength of the components? So again, when it comes to 3D printing, you don't have initial setup time, you don't have initial tooling time, and that's where 3D printing is a game changer. Most of the customers or some of them have tried 3D printing, but it does not work for them in terms of 3D printing. Two things: one is the accuracy or the tolerances, and second is the strength of the fixture, mechanical properties. We have taken care of both the solutions, and we can definitely talk and connect, and we can discuss this on one-on-one level. So with that, fixture can arrive on time, not limited to 3D printing, as I said again, but through various possibilities and fixture made. And yeah, so what we are going to do is post this workshop now, post this webinar. We can set up a one-on-one call with you. My team can send you a link on chat now, and we can also share PPT highlights if you have a request, right? And some case studies with you wherein you can connect, and we can connect and maybe discuss, some of your design cases or fixture cases where you need help. So we'll go to question and answer now, Q&A round now. Okay. So I think we have an overall question, Kaushik. This is about they're interested to know the accuracy of the fixture, right? So yeah, I think you can explain it from the software perspective, maybe, and then I can talk about the process, or maybe from the point of view of 3D printing. Yeah.
Okay, perfect. So when it comes to software is a digital asset, right? So if we set 10.1 on a particular support dimension, and it will still remain 10.1 at the end of the day. But there are few factors that we need to consider, because the file that you are importing inside is in STL format, which means it will always be tessellated, and we should ensure that the file that we are actually importing in is at a good quality, so that all the details are captured. So that is the first thing. And the cavity generation process that we have seen right now, right? It has been made so that it will capture the overall outer dimensions perfectly. So you don't have to worry about that. But if there are some minor details on it, let's say some star patterns or some minute patterns that is available on the surface of the geometry, it might not be captured if it is very less. So our experience is, if it is less than 1 mm, 0.8 mm, then during the cavity generation process, you might not see it. So we should think about that. But overall, the dimensions of the base plate, you can type up to zero point 0.1 decimal accuracy, which means 100.1, 100.2. That you can type in directly. And whatever the STL file or the step file that we are exporting from the fixture mate, it will always be maintained the same. So that is from the software's perspective.
So from the hardware perspective, again, when you come to 3D printing as it is, the accuracies may differ because of the size. It would change. However, better accuracies can be achieved if we can add more offset and do micro machining of the component. So you can still get 50 to 70 micron accuracy if we're 3D printing and micro machining on that. But again, this depends on the size and type of the fixture. So we'll have to look at the particular use case and then discuss this. But as it is 3D printed, would have something around 150 micron plus minus 150 micron accuracy as a standard one when you are looking at 500 mm build size, fixture. Right. So again, there is a question for maximum job weight and limitations. This depends on the fixture and the size and the coverage area for the job. I think we'll have to look at the design and maybe decide and discuss on this. We have another question on what would be the difference between traditional fixture design to additive fixture design. I think we have covered that, but if you want to highlight, Kaushik, about this.
Yeah, I mean, when we talk about traditional fixturing, right? Traditional fixturing or traditional machining fixturing. So we have standard components like B blocks and standard components like biting clamps, etc., which are available out there. So always we have to do a lot of manual tasks in order to fix the geometry. But what if the geometry is completely a different shape that there is no direct way to do it? So in that case, then I think the additive manufacturing would be something to look around, because there is no limitations in manufacturing, right? When it comes to 3D printing, you don't have any limitations on the fillets or what are the corner radiuses or anything. Is completely free in terms of designing complicated, intricate structures. So you should think of it. So if your workpiece is bit complicated, then additive manufactured fixtures would be suitable for you.
Right. Right. Perfect. So, one more question we have from some anonymous attendee, but do software support threaded feature for holes in 3D printed fixture? I think, I mean, let me answer this maybe, Kaushik. So I think the software can
Mhm.
support holes, and you can use thread, inserts maybe. But then right now with 3D printed components, having threads is not a long-term option. However, you can try, but yeah, I mean, is it available in the software, Kaushik?
Software, no. We don't offer threaded options inside the software. So what we offer is a simple hole. So you can always look up at the threaded inserts data sheet. What is the hole that you need to maintain? Directly type in the software. It will be made as a simple hole. Then as a next step, you can do thread insertion operations at the later stage.
Yeah. Okay.
Yeah.
Um, so one very interesting question we have, can we create multi-axis base plate? Because sometimes we need to create fixtures in multiple axes.
Multi-axis base plates. Okay. So it is not possible with Fixture Mate, if I understood the question correctly. So we only support one base plate, which is always facing the Z direction at the top. So yeah, there is no option to make the base plate like this. But then you have to think creatively in order to think about how I can design my fixture with the base plate seeing up, if that might be a solution to you. But the short answer is no, we don't support multi-axis base
Multi.
plates.
So one of our friend, uh, Sheikh Mubarak, has asked one question. Once a fixture CAD is made in Fixture Mate, can the user download a report which shows the parameters used in designing and developing the fixture?
So what do they mean about parameters, like the dimensions and stuff?
Maybe yes. I think so. Dimensions
Maybe.
or
Okay.
tolerances. Yeah. Uh, yeah.
Uh, I mean, we support a PDF export, right? In that PDF export, we show different views of the actual fixture that they have made. We will highlight the maximum dimensions of the fixture plate. If they have used perforated plate, right? We will mark them what are all the screw holes that they need to think about. Probably let me try to quickly generate something so that uh, we can even see it. But yeah, other than that, we don't support any other formats. Let me quickly grab the screen so that,
Okay. I'll just stop my screen share. Just a second.
yeah.
Yeah. I think I've stopped, right?
Yeah. So when we talk about the information generation or a report generation, right? So we have a PDF with all the default views, top view, front view, right view, etc. And we show a plate in which maximum dimensions is marked, and you know which points to use in terms of fixing it. So the operator can, or the assembly person can look at this PDF point and they can understand, okay, this is the point where I need to use clamp, because you can see the clamp is marked in a dark region, so you know which one to place. So with this information plus this information, they can they can understand which location that the actual part goes in the standard comp.
Right. Right. We
Yeah.
have few more very interesting questions, Kaushik. I think a lot
Yeah.
of interested and engineering and very detailed questions. So will this software
Okay.
work with scanned files to create fixtures? So I think they can have 3D scanned files and they want to create fixtures. So will this software work
It,
with?
it will absolutely work. It will work because at the end of the day, it is an STL file, so the software cares about it. But you should ensure, like during a scan, because nowadays even mobile phones can scan parts, but the problem is there will be a lot of
Data
unwanted
loss.
details from the surroundings which are there, right? Yeah. So you cannot remove anything from the workpiece inside FixtureMate. So you need to do some pre-processing, remove all the unwanted stuff, and then if you bring it back to the FixtureMate, it can work perfectly.
Understood. So you need a
Yeah.
very clean and accurate scan file, but it can
Yeah.
work with Fixture.
Yeah.
Okay. One of our friends from Germany, Kostub, is asking, what are the critical considerations taken into account while designing welding fixtures? Okay.
Okay.
So, yeah,
Uh, Probably Swapnil would be more experienced to answer it, but I can just give you from the software's perspective, right? What we care about in the software is we need to know or orient different parts in a right orientation, let's say. So when you're exporting the STL file, you can export the entire complex pipe bend along with the interacting region with all the notches. You can export it as a single STL file and then bring it to the fixture mate and then create supports and cavity structures to it. So what it does is you can take up individually notched pipes, put in the respective cavities. You can even label them just to understand which pipe goes in which cavity, then lock it up with clamps. We can leave the region which is used for welding without any disturbance, and then we can do it. So from the software's perspective, this is the short answer. Yeah.
yeah. And I think from the 3D printing perspective, usually welding fixtures, if it's a laser welding, it's very well possible. You can have a fixture that is durable because the temperatures do not increase beyond certain limitation there. But if it's a MIG or TIG welding, we do suggest to have metal contact plates in between. So maybe if you want to get in touch and understand, we have certain more case studies that I can share with you, Kaustubh. But in between, if you have metal inserts and plates, that ensures the polymer component or the 3D printed component, does not come in contact with the hot, welded component. So that's one option here. But usually, if it's that is not an option, then the welding fixture is there for initial trials and sampling in terms of very complex continuous run TIG or MIG welding, operations. But for laser welding, this is going to be really very helpful. Um, okay, so Tanay is asking, is it possible to make fixtures for VMC applications or kind of heavy applications for machining and milling? So I think, Kaushik, we can still develop fixtures for CNC milling as well. Like fixtures developed on fixture mate can be also used for CNC milling and machining, right?
Yes, because we support step exports as well. And yeah, but at the end of the day, you need to ensure that the size is not too big because FixtureMate is an online software at the end of the day. So if you import very big files, it will not be performant enough. So if it is a small part, let's say lesser than 800 or 800 you can
That's
import it
still
in
bigger.
FixtureMate.
That's still much
Yeah.
bigger. But yeah.
Yeah, you can do it. Yeah. But the thing is, it should always be, we should also think about the removal direction, right? FixtureMate always supports up and down removal direction. So if you keep that in mind, we have clamps. The main point is you need to restrict the degrees of freedom that you can do well with FixtureMate. Yeah.
Got it. Right. We have Mr. Santosh from John Deere. He's asking, how is it useful in heavy structure assembly fixtures with unique fixture elements number more than 100?
Unique fixture elements. If I mean, I'm not sure if I understood it correctly. Fixture elements, as in like different clamps and stuff.
Yeah, more
He
than 100
means.
clamps. So maybe it's an assembly with a large component, but at least 100 clamps and 100 sections, maybe. Yeah.
Okay. If a file is that big, that it requires 100 clamps to clamp it down, then probably Fixture Mate is uh, not
The
not
answer,
very
yeah.
suitable, I would
So,
say. Yeah.
yeah, but we'll have to check the size and the file size. It depends on the file
Yeah.
size, so we can look into it. I think we'll have to get in touch with them and understand and how this
Yeah.
can be done. There was another example and case study that you shown, towards the end. It was about I think a tube structure and a harness structure, where I could see
Hmm.
you have 3 to 4 segmented fixtures for, and those were mounted on a build plate on a back plate.
Hmm. Yeah.
I think something like that also would be possible, where you have segments of these and then they are all set, and then it can work, but this needs to be looked into, I think, on one-on-one level. Santoshi, we would
Yeah.
love to get in touch with you for this. Um, okay, any case study on acceptance and inspection fixtures for gauging? I think yes, we did show a CMM fixture, I think, right?
Yeah.
Go no go
Yeah.
gauging.
We
Yeah,
should. Yeah. Go no.
yeah,
Yeah. It is
yes.
possible. Mhm.
And very interestingly, you also had a radiology fixture also available, which was
Hmm.
possible
Hmm.
there. Yeah, right.
Yeah.
Um, so considering the wear, what is the operational life of a 3D printed gauges which will be used in metal components? So very interestingly, we were also looking into this, and we did work with a lot of companies for this. There is an option with additive manufacturing that you can build the fixture in a composite material with like nylons or polypropylene, and also have a capping with wear resistant material like polyurethane, and the fixture still has amazing wear resistance. So this can be discussed, but this again is for very specific case. We'd like to understand your application, Sheshadri ji, and sorry, Sheshagiri ji, and take this up. Really sorry. um, okay, Kaushik, this question is for you. How do you maintain privacy of the files, our files uploaded to the platform?
I said multiple times that it is a cloud-based software, but we don't store any information on it. So once you close the tab, whatever information that you have uploaded is completely lost forever. So we don't keep any track of it. We have strict security laws in Europe, and we adhere to it. So you don't have to worry about your complicated data being leaked or something like that. We have great customers, right from Audi to Deutsche Bahn, who take data privacy very seriously, right? So we are catering to them, and you need not worry about it. And what we even recommend is just try to save your session files. But saving, I don't mean it is saved online. You should save it in your local at the end of it, then restore it.
So you mean to say that when I'm working on particular fixture design, when I've uploaded, after I close my session, all the files will be deleted from your servers. And
Yeah,
again, even if I want to access the same fixture design, I cannot until and unless I save the session file and upload it to the fixture mate. So
exactly.
nothing is saved on your server, and you're guaranteeing,
Hmm.
right? I mean,
Yeah,
yep.
it is true. Yeah.
Perfect. Perfect. Okay. One more very interesting question we have, Kaushik. We have a lot of questions. I think, yeah, this is
Okay.
possible. Is it possible to add hardwares like double pins and bolts, etc.?
Hardware is like double pins.
Yeah, double
Probably
pins
I
and
did not
bolts.
understand what.
These are just the locking pins, dial pins, which fit in
Double pins. Okay.
double pins,
Hmm.
yeah,
Hmm.
and bolts,
Okay.
etc. into the design.
Uh, Currently, it is not possible because we are not going to make anything with it, right? But if you have a specific use case or a specific need with a particular clamping structure, you can always reach out to us and we will try to find a solution for you. But now it is there is no option other than the standard options that you I have shown in the
Right.
during my presentation. Yeah.
So I have one more question. This is for me, I think. How to maintain RA value and surface both process design and 3D print? I think process design, RA value, maybe you can. So they're talking about the smoothness and the finish from the process and 3D printing perspective. I think on 3D printing perspective, obviously when you are 3D printing, it's going to be layer by layer. But as I mentioned, the software FixtureMate has provision for adding offsets inside and outside both the sides, and then and you can do micro machining and then have an amazing finish. We're also developing a hybrid 3D printer which can do 3D printing and CNC milling on the go. So that's where this is possible. But in terms of software, Kaushik, would you like to answer this? How do you maintain RA value, or is there any specific RA value, or it is just mimicking the component that is being added to the software?
So in the back end, what it does is STL files are already tessellated, right? So
Yeah.
the STL file, when we talk about it, it is made up of multiple triangles. The software tries to reconstruct the triangles and then take the cavity structure. So that is what it is happening in the background. So because of this specific reason of reconstruction and tessellation, if you have a minute feature in your cavity, it won't be replicated in the fixture mate. So what we recommend is whatever it is greater than 1 mm would be captured. And but rest assured, whenever it is an holding case where it is when we are thinking about the bounding box or the touching region, that will be always replicated in a good way. And we can have, as you mentioned before, we have offsets, positive as well as negative. So you can always adjust it to your needs to do it. Yeah.
Right. Right. We have one question: how do we take advantage of FixtureMate and how do we get access? So you can get in touch with us. There is a link here, and maybe you've got the email as well from Divide by Zero for attending this webinar. You can reply to that, and we'll get in touch with you, understand your requirement, and basis that we will provide you with the suited FixtureMate package and how it is going to work for you. So yes, you can talk to us and we'll help you get access to FixtureMate. Someone is asking, do you have 3D scanners? Yes, we can help you with that. If you can get in touch with us, we'll help you. Uh, Kaushik, I think they're liking the FixtureMate a lot. We've got few more technical questions, and they're really good questions. Can we make changes to existing printed fixtures? Alternatively, can we additionally add supports later? Like, uh, if there is any, can we make changes to existing printed fixtures? First of all, I think if it's already printed, making change on the physical level, I don't think so that's possible. If you want to do micro machining, as I said, it's possible, but you cannot change it much. Um, Again, with 3D printing, you can have if your fixture designs can change, you can go and use the grid strategy. So you can use a standard aluminum grid plates and then change a particular section of it, 3D print. But Kaushik, to you, can we add additional supports later? Like maybe, like in pre-trial stage of manufacturing, we have designed one fixture, and maybe you need to say add more supports or something. So how does that work in software?
They should have saved it as a session file, right? So not an STL file, because STL is the exported file, but you need to actually save the FixtureMate session file. So which is the save icon that I showed before. You have to click it and save it and store it safely in your local. Then you can restore back and make changes to it. But if
Right.
you have
So
missed the session files, we
nothing
cannot.
is possible. So,
Yeah.
I think I'll reiterate this, that FixtureMate does not store any data on their servers. It's deleted as soon as we close the session. But however, you have possibility to download the session file and store it in your computer or server wherever you want safely. If you have that file, you can edit and make changes, upload that again to FixtureMate, and then make changes to the existing fixture design. Right?
Yeah,
Okay.
exactly.
Yeah. Uh, Again, there are again, in terms of FixtureMate, there are different packages, and we can discuss one-on-one, and maybe let you know what works for you. I think we can get in touch and maybe make you understand about packages, Sheikh Mubarak, for sure. Okay, we have last two questions now. Yes, we have. So the question is, what will be the strength of 3D printed parts as compared to cast nylon fixtures? Does it solve the purpose? Can we see the example? Yes, we can. We can also help you get some of the samples done. And these are printed in composite materials, so they have really amazing strength. They are comparable to cast nylon and much faster and cost effective for sure. So this is an option available. We can get in touch. You can get on one-on-one call. And one last question we have is, okay, so machining. So what is the life of machining fixture? And threading can be done manually, or we have to do it on 3D software. I think I'll answer this for you, Kaushik. So with the
Mm-hmm.
software, if at all it's a M5 threading that you need, maybe you can add a M4 or M4 or 4.2 mm through hole in the fixture design itself, and you will have to do the threading. If it's a CNC machine fixture that you want to use, like from Fixture Mate tool, as it is, it can be exported from in step format. However, threading option is not available in the software, if I've answered it right, Kaushik.
Yeah,
Right.
yeah, exactly. Mm-hmm.
Right. And machining fixture life again depends on the design. So we'll have to get in touch with you and understand what is it that you want. And maybe we can simulate and tell you what would be the life,
Mm-hmm.
for sure. Yeah, I think that's it with the questions here, but I can also see yes, I think there is. Are there any possibilities of collaboration with the academia? I understand the context is different, but yes, we can look into this. But again, on individual level, we'll also have to talk to Fixture Mate and Trinkle team, and if the interest matches, we can definitely align this for sure.
Mm-hmm.
But we can definitely start the dialogue and understand. Yeah. Okay. One last question here: how to validate the fixture? Mr. Prashant Gupta is asking how to validate the fixture. Kaushik, is there any particular answer you have? Prashant, you can unmute yourself and
Uh,
ask. Yeah.
I don't have any answer to this. I in my mind the answer goes is like we can directly 3D print it and just give a trial run, right? So that is the answer that my mind is going, but I'm not sure if I've answered it correctly. But we can check it up and get back to you later. But there is
Right.
no
So
software options available to
yes,
validate.
yes,
Yeah.
yes. There are two things here. Definitely, as I understand, and I've worked with some of the companies practically on fixture designing. You have a 3D CAD design for the particular component. Then you
Mm-hmm.
get 2D designing, and tolerances are given, because once the manufacturing is done, you know what are the accepted tolerances. It's decided. Post that,
Mm-hmm.
usually with normal process, you go for CAD and you design the fixture with those added tolerances. When you say
Mm-hmm.
validation, they want to see if it is mating or not, if the part is fitting in or not. More or less,
Mm-hmm.
that requirement is being taken care, because while we define uh, the cut or or we define the process in fixture mate, there is an option to
Mm-hmm.
add the offset there, if I may say
Mm-hmm.
this right. Maybe I'm not
Mm-hmm.
using that
Yeah.
technical term, Kaushik, but what I can see is you added a 0.2 mm
Yeah. Offset, global offset.
offset,
Yeah.
right? Tool offset, right? So
Yeah.
such offsets can be added or reduced, so as to your tolerances or with the 2D designs, and validation requirement is reduced to greater extent in that way. But yes, um,
Mm-hmm.
okay, fine. We have more questions? No, I think that's it. So yeah, thank you everyone for joining in. Thank you, Abhishek. Thank you, Ajesh. Thank you, uh, Chali Jayaji, if I've produced your name right. Charan, Gaurav, Himant, Hiren, Kamal, Kaustubh, Kedar, Kashin, Lakshmi, Manjunath, Mukesh, Muthukumar, Naresh, Omkar, so many of you. Padmanabha, Prajwal, Prashantji, Rohit, Sachin, Sandeep, Santoshji, Shrikant, Sheshadriji, Shirin, Shamji, Shrikant, again, Sunil, so many names. Uh, Hundreds of you. Vipulji, sorry if I've not pronounced your name right. Tanay, thank you for being here. Thank you for connecting. We are happy to help you with any of your fixture requirements, and your questions were so relevant and important to us. We can answer them in depth on one-on-one call, and maybe get in touch with you to solve your problems. As I said, this is not limited to just 3D printing, but this is a design solution. So it can be 3D printing, it can be CNC machining, but the software is something that I've personally tried, tested. I've been following FixtureMate for last 3 years, and I'm glad that we can be their partner and bring this to India and to all of you all together. So thank you, Kaushik, for joining in from Germany, and
Thank you so
yeah,
much.
so thank you, everyone. Thank you.
Yeah, thank you so much, everyone, for joining it personally from my side once again. Yeah.
Thank
There
you.
are interesting options available online. You can always check about FixtureMate in the YouTube to go over the other features as well. But just as a closing, but thank you so much for taking your time and attending this. And personally, thank you once again, Swapnil, for organizing this wonderfully and answering all the questions.
Yep. Thank you. Thanks.